Fine.
This meeting is being recorded.
Ooh. All right. Well, welcome everybody to the July meeting of the Seattle Robotics Society. I am glad that you could show up here and enjoy a little of our banter there from if you've been online for the last few minutes. I'm going to go ahead and run through the agenda here pretty quick, and then we'll get on with the rest of our meeting. So we're going to kind of do this, follow this agenda here. We are recording, so do be cognizant of what you say and share. Make sure you don't share anything proprietary or anything like that might get you or somebody in trouble. If you are, let's see, I guess I should go to my slide. If you are not talking, please mute your microphone so we don't get any background noise. I think I better shut, my next door neighbor is cutting his grass there. I don't know if you could hear the lawnmower behind me, but I'll close the window. But post questions and comments and other things into the chat window. Which I guess I should be able to see somehow or another. It doesn't look like I can actually at the moment, so I got to figure out how to do that. I will fix that in a bit here. Let's see. I have had a couple of people asking about, hey, are we ever going to have physical in-person meetings again? And it's like, well, so right after last meeting, I emailed Kevin Ross and asked him how the new facility is coming together, and he said, well, definitely not this month, probably, possibly next month, possibly. But they were having there was some work, remodeling work or something that was being done. So not necessarily available yet. So at this point, it's like, I don't know. I really don't know when we're going to be able to. So just stay tuned. I'll update the website once it happens. But if you're interested in, you can Google that address that you see on the screen there. That will get you, though that will only get you to the road out front. You got to go back, all the way. You'll be a driveway that goes east in front of you when you reach this location, and you go pretty much all the way to the last suite or warehouse on the right or on the south of you, and it's probably labeled. I'm pretty sure it's labeled on the door, so you'll be able to tell when you're getting close to it there. And there's one more facility, and then there's fences and railroad tracks beyond that. So you're welcome to go by there and check it out if you happen to be driving through the area. Website, I won't really say too much about that. Nothing has changed on this, but the old website is available for you to reach from the new website. So there's an announcement block on the front page there. You can go jump and you can access all the old content. So I'm a little bit hesitant to commit to in-person for August because I'm actually not going to be able to run this meeting. So I'm in the process of looking for somebody else to run this meeting for me for that month. And it will require, probably some setup of equipment and other such at the facility to be able to give anybody who wants to zoom in the visibility and be able to hear what's going on and all of that. So I'm a little hesitant to just sort of toss that to somebody else and say, well, you make it happen, So anyway, but I will, when that does start to happen, though, there will be a kind of a regular need for assistance getting that put together and set up and keep it running. So keep that in mind if that's something that you would be able to assist with it in the in-person events. I have officially launched my virtual weekly kids robotics class. It's going to be a fee-based class. I'm targeting middle school age children, probably in the 11 to 14-year-old range. So this is going to be kind of a beginner introductory level particularly for kids who've not really had any exposure to this stuff. I made my announcement on my Facebook page, so you can friend me and then you can get in there and take a look. And then I have a private group where I'm actually sharing the details of all this, of what I'm planning to do and how I'm planning to do it. Still figuring out how much I'm going to charge, but I'm going to try to make it reasonable. I'd like to have kids and parents be comfortable with what I've got to offer and what it'll cost. So anyway, you can reach out to me at my email or at the club email, and I can I'll point you to more information. Not sure about upcoming events. I know there's lots of things going on the front page of the SRS website. There's let's see, we've got the we had the Pop Can challenge test run. So that's come and gone. We've got we've got a virtual exhibition, which I'm going to talk about later. And then there's the Pop Can Challenge contest itself, which will be happening in October. And then there's a link that gives you robotics activities all over the world. So you can visit those to find out other interesting things that you might want to either participate in or at least attend and watch. Solicitors, doing pretty good on solicitors. I'm booked through the end of the year, so that's great. I'm gonna continue to kind of touch some of the ones that I've sent. I sent a whole bunch of emails out last month. I need to just ping those folks again and just make sure that they heard me and see if I can find a few more. So here's our lineup. You can see we've got James Newton's going to talk to us about WireBots today. And then we've got some other interesting things kind of down the road and currently open starting in January. So if anybody knows of somebody that might have something interesting to share, or if you have something interesting that you'd like to share, reach out to me and be happy to plug you into a slot. So use the club email there. We're going to have let's see, as you saw there, in the December, I'm planning this #1 here, telemedicine and remote patient monitoring, or RPM, which is becoming a thing. And, you know, for those of us older guys who are very accustomed to, you know, traveling to doctors to have things done, and, you know, you go into the office to get stuff measured and things like that. Technology and the interconnection, and Internet of Things is allowing more and more of that stuff to be done remotely. And so we're going to have an open discussion. We're going to talk about the technology, and I'm just going to kind of throw up things that I found out on the internet, and then we're just going to talk about those. So feel free to, please join us for that. That should be great fun. Let's see, what did I say out there? Oh yeah, okay. And then this is just a sampling of what's coming up here then. So James Newton's going to share with us about something that you may or may not be aware of. You've certainly seen the result of it if you've ever watched professional sports, but you may not have been aware of what was actually making it happen. And so we're going to get a little behind the scenes look at how this wonderful technology works. So stay tuned for that after the break. Robothon, and since Lloyd's on the line here, I'm gonna go ahead and let him talk about what's coming.
Okay, so we're basically going to do our virtual exhibition event again. I think this is the third run of this.
Yes.
We've done 3 of them. Anyway, it will be August 27th. From about 12 to 3 p.m., kind of depending. We'll definitely start at 12. When we end will depend on how many presenters we've got. So far, we've got about 6 presenters now. So we picked up 2 more since the slide was done. So I think we're going to have a pretty full agenda. We'll basically, in the next few weeks, be sending out the meeting link and the times, and just show up and we'll hang out for a few hours. Yeah, that's all I got to say on that.
That's all you got for that? Okay.
Apparently I'm emceeing the event, so I'll say more then if you're not sick of hearing from me already.
Okay. So yeah, and you can go to the well, I guess we do we have any backup? Do we have backup people?
Yeah, there's
on
one
the
back
list?
so far. We've actually
One
got
backup?
7. Yeah, we've actually got 7
Okay.
registered with 2 tentative. So
Okay.
we're going to be
Okay. So
somewhere between 5 and 7. So I averaged and said 6.
yeah. Okay. So and do, feel free to go ahead and, if you have something, get on the list, because these are pretty easy to do, and if we get enough people to do another event, we'll just schedule another event. So okay. Anybody have any questions or anything about that? All right. Let's see. I saw Chaz online there. You want to chat a little bit about the PopCan Challenge, Chaz?
Yeah. Well, it's upcoming. I don't know how many are coming. We have this weekend, actually Sunday, we have in the Sunoco Maker Space our annual auction. Why is this related? Because we have to move some stuff out of the way for this PopCan Challenge. We measured it out, and the arena just fits inside the maker space itself. We were thinking that we are going to have to move it somewhere else, but thankfully we talked to everybody that was interested in being a contestant, Greg and everybody that showed up for the pre-test, and we're going to drop a tiny chunk of the course that is not normally used. It's like blank space on the far side of the arena, but just for convenience purposes of setting up this arena. But I think we have all the things we need for the arena. We're not going to need the arena down. Presumably that's at the first location. I'm sure they moved it down there. So we built kind of a second one so that we could host it there. The walls are the same height. We won't have the exact same table. We'll try to replicate it so it's the same, but it should be pretty close, unless somehow we get access to it from now to then, but I don't think it's required, particularly with who we know that's going to attend this thing. So if you have any questions about it, or it's not just for people to come and run, come and watch if you want. There's plenty of room to just hang out and look at it. I honestly, during the test event, I think we ended up talking more about our robots than getting to run them, which was fine. It was really fun who doesn't want to talk about what they've poured so much pride and joy into. So so yeah, it's come and join. It's free, there's course, and you'll get to see us run our PopBots, our PopCan Challenge robots.
I just out of curiosity question, do you guys have any videos on YouTube or anything of the test event?
We ran a Zoom, but I think I forgot to hit record. So,
okay.
No, but I'll try to record it next on this.
Yeah, it's okay. It would just be kind of fun to just get a little bit of a taste of what what it's like there. So okay,
yeah.
Sounds
I'll
good.
ask Greg to help me remind to click.
Yeah,
I just set up the lap. I have a little telepresence like Logitech camera, and I just plug it into the laptop, and it does an okay job with the audio because it has a speakerphone on it, so people can talk if they want to and ask questions. But yeah, I'll click record.
Okay. Yeah, it's we're when we do our in-person meetings, I'm a little bit concerned about how folks coming in are going to be able to hear people, because we're going to be in a large open space, and sound doesn't tend to carry nearly as well as it does when you're sitting right in front of your computer. So being able to understand what people are saying and hear their questions and answers and things like that. So yeah, there's a lot of kind of tricky stuff when you sort of shift from something like what we're doing right now to, okay, we're going to have, we're going to bring people from the outside into this big, large open event that's either happening in a big space indoors or outside. And, how do you get more than just the video, where people can actually hear what's happening and engage with people. So,
yeah.
So anyway,
so far is that what happens is that we have online events, and then they try to do hybrid events, and they run into exactly the problems that you're talking about, Steve. And then what they do is they give up and they go back to doing just in-person events and drop the online events, which would absolutely break my heart, because I love hanging out with you guys from down here in sunny Southern California. I really want to make it work.
you know, I hear you, and I really want to make this work somehow. So, you know, I'll be looking for any support I can get from anybody, and trying to make this work so that we can do this for you guys. Because I love that we've got people like you from far away that can join us.
So the other thing that I have seen happen, actually in a couple of the groups that I'm a part of, that does seem to work, is they start holding 2 events. Either they ping pong back and forth. Like if it's a monthly event, they like 1 month it'll be online and the next month it'll be in person only. Or they'll do, you know, like 2 events per month, 1 online, 1 in person. And that also seems to work pretty well. It's kind of nice. It can be like the, you know, Seattle Robotics Society outreach meeting, and then the Seattle Robotics Society in-person meeting.
Yeah, if we end up needing, I mean, you know, to your point, James, the reason I think a lot of people shy away from it is because we're using laptops, and laptops, you know, the volume is cranked up. And I think, you know, probably a number of us have set, like Lloyd for sure, I imagine, has sat in on or hosted training events for, you know, during COVID. And it's really difficult when you have a room full of like 5 people or 10 people or whatever, and then you have 5 other people sitting on the computer and you can't hear anybody. And that's because you're just using, you know, your standard laptop that's just meant for this, right? Just face to face. So you just need different equipment. And I mean, you alluded to that, Steve, right? So if you need some stuff, I have, you know, a couple, you know, decent, okay microphones or that sort of thing where, you know, like the directional microphones will cut down on all the noise of people coming and going and side chats and that sort of stuff. So
yeah. So there's definitely solutions to make it work. I mean, people are doing it, so it can be done. We just need to be, maybe we need to spend some money, you know, we need to spend some money and get the right kind of gear. So okay, so we can talk more about that afterwards if you would like to continue the conversation. But in the meantime, I hope, you know, I don't know how many, I'm not endorsing Harbor Freight here, by the way. I just made a note of this 30% coupon that they have. You know, you can get up to 5 items, 30% off each, you know, together when you buy them together. So it's an online coupon. I sent it out on the Seattle Robotics groups. There's the link to it, but you can go online and just search for Harbor Freight. I think they call it Harbor Freight 20% off coupons, but it's actually 30. So anyway, if you need any junk throwaway tools, hey, you know, here you go. I just happened to I got a little bit skinnier. I don't know how that happened, you know, because usually I'm going the other direction, but I got a little skinnier. And so I needed to punch a new hole in my belt. And I had one of their leather punching tools. And sure enough, I couldn't find it. And so I thought, crap, I got to go buy one, but I know I've got it. And of course, as you know, as soon as you go buy something, you immediately find the thing that you were looking for. But then I get there and I find out, hey, this thing is 30% off. Well, now I can just throw the other one away when I do find it. So, you know, it just worked out great. So anyway, with that, let's see. So has anybody got anything to share, updates? Because if not, I took a tour of the Orosat lab down at Portland State University last month, right after our presentation from Andrew Greenberg. So I've got some pictures of that, and I'd love to share those with you guys. But if anybody else has got anything first, I won't take the time away from you. So.
Yeah,
anybody
I
out there?
To share at some point.
Okay, well, why don't you go ahead, Chess? Start.
Okay, so as we mentioned probably 2 meetings ago, or maybe it was last meeting, I don't remember, but we have in, you know, up north at the makerspace, we are starting to do challenges, you know, robotics challenges that are low barrier for people that are interested in getting into robotics. You know, it's, you know, we recognize that we were having these club meetings, and you know, Greg and I were using kind of the same tech. We'd have these talks, and people, I think, were just coming in and it's like way over their head, and they left because it wasn't introductory at all, or at least wasn't introductory friendly. You know, our first challenge is a horizontal rope climbing robot. I think we're technically in month 2 of 4, I can't remember, something like that. But come to the meeting, you'll find out. And I ran a small little version of this workshop for the Snohomish County 4-H Club. And so I just bought these little tiny guys on eBay. They're just a little horizontal climbing robot, and kids put them together in about 45 minutes, you know, and there's no brains to it. It's just a battery and a rope, battery and a motor. But they crawled across the robot. And I think these things cost me like $7.20 a piece. You know, and actually somebody ended up donating all the money for that stuff, which was really kind of them. But the robotics competition that we're, you know, it's not a competition. We're not competing against each other. It's a challenge. But we talked about this, but you know, it's, you know, with the idea is that, you know, you're just expanding your knowledge of robotics, and it's good for all. Like, for instance, I've never done with any swinging mass robots, and I've never printed, well, I printed gears on my PopBot just recently, and I showed that off in the test. But you know, like for instance, this is a you know, 3D printed gear system with motor and everything on electronics. And the idea is that I'm swinging a mass to kind of like, you know, move my, kind of like a kid on monkey bars, right? If you still call them monkey bars, I don't know, but yeah, it's, so if you're interested in just getting started in electronics, it doesn't have to be fancy. It could be spring ran, duct tape, cardboard, and all that stuff. You know, you don't have to know how to make printed circuit boards or anything to join in on that fun. That's what I got to share, unless there's questions.
Okay. All right.
I'll just share real quick that I just finished a week of teaching robotics with JavaScript class for Sally Ride Science down here at UCSD Extension. Had a lot of fun. Kids loved it. It's with the extension, but it's for high school kids. And we teach the kids how to write code in JavaScript at the same time that they're building a robot, at the same time that they're learning how to program the robot arm. Really enjoyed it. And the big news is that UCSD, after I've done this class now for, I think this is the 4th year, they came back and said, okay, we want to do 3 full classes, which will be asynchronous, taught online, which are 10 weeks each. So a small expansion from 1 week to 3 10-week classes. And I'm like,
that'll teach you.
Yeah, exactly. I'm like, there's no way I can do that. But I've been working with another UCSD instructor on another class, and she's really good at working with the content management system that they use, which is called Canvas. And so she's going to take all of the content that I've collected over the years regarding robotics and shove it all into this Canvas thing. And she's going to put together the course, and then I'm going to teach it around the end of next year. So the reason why I'm mentioning that is because if there are things that you know of that you felt were like super, super valuable in your learning of robotics, or content that you guys like students to see, or that you feel is important, that you're able or willing to share, I would really love to get that into the class. So if you're willing to send it to me, please do, and we'll include it. And of course, you know, credit back to SRS and to the individual contributors as well.
That sounds really cool.
So, Steve,
Okay.
I can give an update, but I don't want it to preempt what you've got to show, because I'd really rather see what you've got to show. So,
Would you? Okay.
If there's time left. But
Okay. Well, let me. Okay. So let me get to my. I'll go ahead and share. I'm just gonna share stuff out of my photo album here. So had a very nice meeting with Andrew. He was very, very gracious and kind, and showed me around their space. It's relatively small. Let's see, I'm kind of imagining the size. I'm thinking that it's probably about a 30 by 50 or 60 foot lab area that they have. And so they've got a kind of a, when you first walk in the door, they've got this little kind of a display case with rockets that they've launched. And, you know, you can see from the, you can kind of get an idea of the size of these things. You can see some electronics on the one there. I think I've got a picture. Yeah, okay. There's the, so you see that one that he's got his hand on there, and you can see the electronics payload there that's just below the black nose cone. There's some little stabilizing fins below that. And then the CubeSat is in that little, that orange brownish tubular area that's just below the where the little the fins are. So that's where their satellite payload. And this is basically throwing these things up into the sky and then parachuting them down. So this was kind of their, you know, before they put them on board a rocket that would actually take them in orbit, they were experimenting with the durability of their bills by setting them up on these guys. The one up on the top there, you may notice, looks like it's in pieces. According to Andrew, that one literally folded in half during a launch. So the part straight above, you know, the first, you know, toward the, let's see here, I'm going to point to it. Okay, can you see that there? This area right here, you can see some broken, you know, kind of looks like it was sort of ripped apart, and some of the joining metal joiners and stuff. And then down a little bit further back here, there's also a place where things came apart. So that's their, what would you call it? Their lessons learned model. So, you know, when you have something that fails catastrophically and you can retrieve most of it, there's all kinds of things that you can learn about why that happened, and possibly learn a few things and maybe prevent it from happening again. So, so anyway, that's their, this is their trophy wall, so to speak. And there's a close-up of the fail section of that one. And he says it was, yeah, it was pretty catastrophic because the thing just literally folded in half. There's a close-up of the section with the CubeSats in it, and what you're looking at there are actually they're antennas that are embedded into the surface of the outside of the material. So he's got, I'll show you some other stuff related to that. Let's see. This is one of the, you know, I think this is, let's see here. That is this thing right here, this part. So that is that's just kind of their demo package. And I think I'm trying to recollect, you know, he was just dumping. It was like getting a fire hose of information here. So I'm trying to remember here what all he was sharing about all these different pieces. Well, you can say that.
Raspberry Pi camera down at the bottom.
I believe so. Yeah. And I think I believe that's what they're using as their controller in their satellite. So I've got some better views of the board. Some of you guys may recognize some of that hardware. This was just a specimen. They're experimenting with different, you know, using different kinds of materials. They, you know, when you're engineering structures, particularly structures that fly, what you're, you know, one of your obstacles is you want to make something that's as strong as it needs to be, but is also as light as it can be. And this particular part started out as pretty much just a solid cylinder. And of course, you know, if you can imagine, even if this thing is just made of aluminum, I mean, that's a substantial amount of material. So you can see that it's been machined to take out, you know, to leave these triangles for structural support, but then remove the material in between that isn't really doing anything. And then this particular piece was put into a vertical, oh shoot, I used to work with these machines now. They apply pressure using screws, 4 screws and a head, and then you apply measured pressure at a slowly increasing level until the part fails, to figure out how much vertical, you know, tensile strength this, or not, let's see, it's a compression strength this particular part has. So this is intentional. I mean, this is not from a flying model, but this was experimenting with this to see if this design was strong enough to do the job for them. And it turns out it was. In fact, he says it was actually quite a bit over what they needed. And so one of the things in engineering, this, you might say optimizing the engineering is to make something only as strong as it needs to be, and then, add a little safety margin to it, but don't over design it. Don't design it the way Boeing designed airplanes 50 years ago, where they're built like tanks, and but which is way more than they need to be. Now, the counter to that, though, is think about B-17s and B-29s and some of those kind of planes. Anybody's ever watched some of the online documentaries about those things getting riddled full of bullets and getting hit by surface-to-air missiles and such, and the pilots can still fly those things in spite of that. Well, I have a feeling that those pilots and those crew on board probably are very thankful that those planes were over designed, because that probably contributed significantly to their survival. So on the one hand, they were over designed. On the other hand, yeah, that was not such a bad thing for the people. So here's a kind of a cool one. So you can see some chutes in this one. So you got the nose cone, and then you've got some parachutes. This particular one, I don't know if it had, I'm trying to remember, it's got looks like two of them in there, and I'm trying to remember what that was. So I think I believe it is standing, it's standing in its upright position. So the nose cone, of course, would go on top. And then there's another section yet that goes on the bottom of this piece. So, and the fellow on the floor behind here was working on a stand using that. Oh shoot, what's that cool aluminum structural stuff that's got the little grooves in it where you can put in bolts and nuts, and you can create
80-20 or extruded aluminum or all those.
Yeah, and it's kind of like a Rector set type material. You cut it into pieces. You can bolt it together to create anything you want. So he's making a special stand that has rollers built into it, so they can lay their rocket horizontally on this stand, and then they can roll it to work on it. So he's one of the grad students that works with Andrew, and he was very, it is kind of funny. He talked about how, these guys, these kids, these students do all the work. He takes all the credit, they do all the work, so, but I think a lot of them really enjoy that. So it's pretty fun for them. This thing is really kind of cool. And I know you're not going to be able to see a whole lot from this, and I don't know if there's much I can do to help you with that. Let me see here. Okay, how about that? So I'll zoom in a little bit. So what you can see is you got lots of plumbing, you got gauges, you got pressure regulators, just all kinds of stuff. So this is a rig for fueling, and their rockets, they run on. Let me see. What did he say? It's a liquid oxygen, and it's not oxygen hydrogen like the like our the stuff that NASA launches and the military and stuff. Really dangerous stuff. But it's something that they can use liquid nitrogen to actually chill the oxygen down into its liquid form, and then they can put it on board their rockets. And so the stand itself actually has you see these wheels on top here. So it's a portable rig that they can lay this thing down on its side and then wheel it to wherever they're going to do their launches. And then here's one of their little guys with the tape measure antenna system deployed. And this is very clever. I really enjoyed seeing this in person, to be able to get a good look at this thing. So you see, you've got the different, you've got the four different clusters here. And of course, this is now fully deployed. And the lengths on these things, the tape measures were very convenient, because when they built these antennas, when you're designing an antenna, the length is how you tune the frequency that antenna optimizes at. And so you can see there's 3 different frequencies for the 3 different antenna lengths. And when they're stowed, you've got these little caps. So this is a 3D printed part with the hinges on the inside here, and then you've got this cap that goes over the top of these things and keeps them in place. And he showed me how they stow the antennas. They just kind of stick a pencil through there, and they just kind of spin it to roll the antennas down in there. And the short ones are pretty easy to get in. This longer one actually has to be rolled up to get it inside there. They put the cap down, and then they've got a little piece of filament that goes underneath a resistor that's in this back area. Let me see if I've got let's see here, get that. It seemed like I had, there we go. Yeah, there's the little resistor, and you can see the little that's like a little I believe it's just like nylon fish line or something like that runs from the edges of these things up over underneath that resistor and then onto the opposite side where it gets tied down. And they just run power through the resistor. The resistor gets hot, it burns through the filament, the tops pop open, and out come the antennas. And it's just a wonderfully ingenious and simple and reliable mechanism. And you send stuff up into space, you think about these complicated things like take the James Webb telescope as an example. Talk about a complicated piece of hardware and having so many moving parts that all have to deploy and position themselves in exactly the right place and time, and everything has to work. And these guys are doing the same kind of thing, but they're doing it on a budget, and they're just, it's super simple, and it's just kind of wonderful how that actually worked for them. And he says this is just great. It works very reliably for them. Here's a camera board. So anybody say anything in particular about this one? That
interesting. Whatever it is in the middle there with the ball grid thing. Did you know if they were using FPGAs or if they were using processors?
Yeah, I don't remember the
FPGA, but so these go into,
go ahead.
Steve, these go into low Earth orbit. Is that what the target is for these?
Yes. Yeah, I think on the order of 250 miles, maybe something. Similar to where the space station is sitting right now.
Okay, and then they're expected to last for how long?
Oh, I think they maybe a couple of years, but
oh, wow, okay.
they could last longer, I suppose. A lot of stuff actually turns out it does last longer unless something hits it or you get some kind of a failure. Because of the temperature extremes in space. Yep. It could be hard on electronics, and they're not using aerospace qualified hardware either. Right. They can't afford to send these things through $500,000 worth of aerospace testing. So they're just using stuff. They may use military temperature rated hardware, electronics, but they're just putting it together. And in some cases they have, go ahead.
Oh, I was just thinking about the radiation exposure too.
That may have some effect as well. They do have things in metal, they're metal card cages. So there's some,
so they have some shielding.
I'll show you some pictures of that. I think I've got some down further. So during Andrew's talk, you may recall that they were experimenting with being able to position these things by spinning these little gyroscopic things, motors.
Reaction wheels.
Reaction wheels, yes. And so this is the hardware. They have not actually put this on something that's flown yet. He's anticipating actually having this working by the end of the year. So I know some of you are interested in hearing more about how this works. And so he says he'd be happy to give us a talk just on how this kind of stuff works. And so I told him we'd keep him in mind for that. But this is just a little piece that goes on their hardware. So here's a card cage, and this is a metal cage. And I think when it's all put together, it's completely encased. So you've got metal sides and bottom and top, and so once all the boards are installed on this thing, it's completely enclosed.
Looks like Greg's robot.
Yeah. You remember he mentioned during the talk there about the purple boards. Apparently they just got a really good deal on the company that makes these boards, and it just so happens they make them purple. So he says there's no special reason why they happen to be that color, other than it was just that was the good deal. I love that. It looks like he's even got a little mod down here on the one connector.
Yeah, Osh Park, which makes the purple boards, is in Portland, so I'm not surprised they wouldn't give him a good deal. Yeah.
Yeah, and they probably they may very, very well have gotten a really good deal from those guys, given that there would be publicity associated with them by doing this. So yeah, and he actually had one of these. I don't know if I got a picture of it, but he had a bench set up there where they were running some endurance testing. Yeah, here's their workbench. So they got this really cool drawer full of all the bits and pieces of their satellites. And then this little guy right here is actually undergoing some electronic endurance testing. So it's hooked up to a power supply. It's fully energized. It's going through some software algorithms that are exercising its functions. So, and this is a little, let's see, this is a bench that was actually adjacent to that other one. So picture kind of off to the left side of this image, then there was a second bench kind of at 90 degrees to this one. So they've got a pretty nice workshop set up here for putting these things together. And lots of great tools for the stuff that they're doing. And this is you may recall he mentioned that they want to have their satellite looking down at the ground as it's flying over Portland State, and they were going to have some students out there that were going to be looking up at it, and they wanted to see if they could see themselves from their satellite. And so this is a little 3D printed jig that the students on the ground would hold. They put a cell phone in the middle part here, and then it's got one of these this antennas that microwave frequency antenna. Then this tube that comes off of the other side is I think it was about 2 feet long or so. And then this little guy would then hook up to the receiver on the ground. And so they would point this thing up at the satellite, and then they could hear, and they could pick up the data stream from the satellite as it was flying over them, and then hopefully capture a picture of themselves in essentially somewhat real time or close to real time on the ground. And then this is an adjacent lab where kind of like your makerspace, all sorts of wonderful tools for different kinds of printers, and 3D printers and laser printers and engravers and different kinds of machinery. He says kind of a mess right now. They're in the process of kind of cleaning up and organizing this here. I got a couple of pictures. So here's a picture a little bit to the right of that first picture, but really cool space for working on any kind of project. So this is not this is just a lab they use, a workspace that they use, but it's set up. It looks like it's very well equipped for doing any kind of building. So a great resource for students at the university. And then this was looks like this is a little circuit board. Let's see. And maybe somebody can tell me exactly what I'm looking at here. So you got the different tools around the outside. So this thing looks like it picks up the tools and then it actually grinds
Yeah.
material. Is that what that is?
Yeah, Steve, if that's what I think it is, it allows you to fabricate PC boards, prototype them by routing. So you basically
Okay.
routes off the copper you would normally etch out.
Okay, yeah, that makes sense. Now that you mention it, yeah, that was what it was. So, kind of a cool little machine to have access to, and got quite the variety of bits there to work with, and the machine just grabs what it needs and uses it, and then puts that one back and grabs a different one, and it's like a lot of fun gear to work with. And these are, let's see, what kind of. These are
Look like Prusa 3D printers.
Yeah.
Kind of.
So they've got a duplicates, a bunch of the same machines so that they can be doing multiple parts at once, or different students can be doing things simultaneously. So they've got a pretty, they've got multiple machines of various types of the ones that would be higher usage, and so try just to kind of keep things moving, so yeah, if a student has a project he needs to get printed, there's a good chance there'll be a machine available for them to use. Yeah. And that, oops, let's see here. And let's see, these are, Formlabs. And then these are, let's see, are these the resin? I think those are the resin printers, aren't they?
I think so.
Yeah. So
This is
So
all
they have
really
a couple-
cool stuff, Steve, but I'm gonna be really disappointed if we don't have time for Greg's update about his robot.
okay, all right,
It's not that significant. Don't worry about it.
all right.
Oh, all right, all right. I love seeing that robot in Greg's work, but this is cool too.
I will. Yeah. Oh, okay. This. I believe I'm close to the end here. Okay. Yeah. Okay. I'll zip quick through these things. And that's just a little slingshot type thing that was, made out of wood. Fuel pump for their rockets using a motor that drives a turbo pump. So that's kind of one of their on the future for their making their rockets work. And then this is kind of like.
And that was a BLDC, which with the external rotation, and you see how they're using I think they're using rollers on those little orange mounts have rollers to hold the spinning head. Mm-hmm. Is that what that's for?
I think so.
I've never seen that done before. That's really neat.
It's pretty cool. Yeah. So, and then this is a I think this is a 3D, a metallic 3D print of what would you say? This is a kind of an end view of the let's see.
Is it the fuel injector for the nozzle?
I think so. Yeah. So that view that you just saw is on top of this flange fitting up here. Looking at the top of the flange fitting, and then there's I don't think I took a picture of the other end, but there's an outlet. Yeah, there's the nozzle coming out the other end, and then this is going in. And
it's called the Pentel injector. Is that right? Yeah.
Maybe. Yeah. And then they also have a robotics club there, so we may see if we can connect with those folks. The Viking Robotics, and then they do some fun stuff, and of course they have access because they're right there on campus. They have access to all of that cool gear that you saw, and so they have weekly meetings in their they call their Fab 7009 lab, and then this is a mechanical. It's a magnetic gearbox. So they've got their mechanical engineering students, or electrical mechanical engineering students, are figuring out how to make a magnetic gearbox. And there's a signboard up there outside of their lab explaining how this thing works, and it sounded fascinating to me. So we may see if we can maybe these guys can share with us what they're doing and how they're doing it. It looks pretty cool, believe me. So, okay. So anyway, that was what I had. So I'm going to go ahead and let Greg jump in and you okay, Greg, you got 1 minute and 30 seconds.
Okay,
No,
well,
you can take more than that.
Well, that's all I need because it's very cosmetic.
Okay.
So if you look in the other window that I have hosted there, you can see Gidget there. Gidget's been given new side panels. It's got a new back panel here that can be taken off to get access to what's on the inside there. And all of that kind of just snaps back together when you're not in a hurry. Panels, new panels have been put on, new front panels, arm has been installed. And I don't know if I showed this last month, I don't think so, but there's a lot of things that go along with Gidget. You've got grippers, you've got jack stands, you've got toolboxes, and so obviously I don't want to have to carry all that stuff with me. So when the time comes, Gidget's now got a trailer.
Ah, that's great.
Always got
I
a one up.
love it.
So now Gidget can carry her own gear. So there.
This is fantastic. I love it. What a great update.
That is awesome. Yes.
So that's.
What's the toy that I'm thinking of from like the 80s? Was it the track? Something
Big Track.
There was a Big Track that had a trailer as an option.
It did. Yeah.
It's just reminding me of that. I think the number of different cool experiments that you could do with a tractor trailer system like this. Thinking about self-driving trucks and how big that's going to be. Right now, they're only doing stuff on the freeways, and those trucks can't back up. They're not allowed to. But there needs to be some research done into how a robotic tractor trailer can, reverse and put a trailer in a loading dock the way a human driver could. And I think computers are uniquely qualified to be able to do the trigonometry and planning required for that. So there's your setup for solving that problem, Greg, and making yourself $1 million.
Yeah. Okay. Good. Just what I need. Another distraction. October is going to be here before I know it. Okay. There you go. There's your 90-second update.
Awesome. Thank you. All right. Well, it kind of monopolized the time today. Anybody else got something that they want to share before we take a break here? And yes, no, maybe, sort of thinking about it. Okay. Well, why don't we? I want to take about. I need to run to the little boy's room myself, so I need about. Let's see, what do we got? It was 11:04. Why don't we reconvene about 11:11? How's that? I'll see if I can put up a clock on the screen here so everybody has got that. Let's see. Okay, exact time. All right, go back to Zoom. Share. Let's see. Oh, of course. Okay, I got to do that. Like I always have to drag things off to the other monitor. There we go. All right, there you go. So with that, I'm going to go ahead and pause recording. All right, so 11:11, everybody.
We're gonna have to find Steve an online countdown timer.
No joke.
It only helps if it beeps in his ear.
So I'm anxiously waiting for the mailman to come today because I ordered a Raspberry Pi 4. It's supposed to be out for delivery.
You actually found one?
I found one on eBay. Yes, I am paying a premium. Wasn't as bad as I expected. 8 GB 4 for $110.
Oh yeah, gosh, that's not too bad.
Yeah, not bad.
Vision systems, or imagine that's for
What's
Gidget. That's for
Oh
Gidget.
yeah. I have been pulling my hair out, and there's been a ton of cursing trying to get the Real Sense library compiled, installed. I don't care how it gets on. I mean, I had it on one a couple years ago, but I overwrote that SD card, and I thought, well, you know, I'll use the latest version of this, that, and the other thing. I cannot find a winning combination. So I have come across some, you know, Raspberry Pi 4 specific instructions. And so I thought, okay, maybe given that it's more recent, the instructions are more recent, maybe they'll work with, you know, maybe it'll be a combination that works. But
Yeah, I had a Raspberry Pi for 2 gig that I have it working on. I haven't done anything with other than testing, but I don't know if you can't get your image to work, I'll give you mine. And
how long ago did you put that image together?
I don't know, not more than 6 months ago.
Oh, okay.
Somewhere
Yeah. Well, that gives me some hope that I'll be able to do the same.
Yeah, I don't. It was a lot easier than the first time, like you said. I think I originally did it with a Raspberry Pi 2, and it was when I first got that D450 or whatever the model number is for it. And it seemed like it was a pain then, but it was. I was ready for a fight, and it seemed like it went pretty easy this time.
And which OS did you use?
Ubuntu.
Okay, yeah. You know, because I'll find instructions that talk about how to do it with the Raspberry Pi OS, and then, you know, oh no, other people are saying, oh no, it works better with Ubuntu, and then you go to the Raspberry Pi OS installer, and you click other OSs, Ubuntu, and then you've got version 22, you've got version 20, you've got desktop, you got server, you've got 32-bit, 64. It's like, oh geez.
Yeah, you remind me of so I started with like not what the thing said. I'm like, well, I'll just use the newest one, right? That should be no problem. I think it was 21 something, right? And I ended up like, you know, cursing quite a bit and saying, dummy, why did I try to do that? So I had to go back to like 2004 LTS or whatever the 20 LTS version.
Well, that's the one my most recent. Every time I'll put an OS on an SD card, and then I'll go through, you know, a bunch of steps, and I make a text document of all the steps I went through, and web page, you know, pages, web pages.
The resource.
Where I got, So I make this text document. Well, I got 8 of those text documents on my desktop.
Nice.
And nothing to show for it.
How not to do it. 1. How not to do it. 2.
Do not follow any of these instructions. They do not work.
Yeah. Surefire way for disappointment.
Exactly. And a few of them, the build has been, I swear, at least 12 hours. because I'll start it before I go to bed, and then I get up in the morning. It's 82%. It's like, oh, geez.
Yeah.
Anyway.
Well, that's all right. You got it. I mean, I used to work off those little tiny like plug-in LCDs, and I gave up on that. Not only is it like a pain because you're always like you got your eyes down on it, to try to figure out what you're. But you got, I imagine by now you got a whole monitor and keyboard and mouse set up, right? So it's nice, and handy.
Well, yeah. So I have a monitor keyboard plugged into the Raspberry Pi, but I also have the Mac communicating to it, either SSH to it or just a serial console, because often these things you have to type in, they're long strings.
Yeah.
So I'd rather copy and paste it from the web page right into the terminal, as opposed to trying to retype it over on the Raspberry Pi. So yeah.
What
I
are we
was
talking
wondering
about in general. I missed the start of this conversation. What's the Raspberry Pi doing or controlling?
The Intel RealSense 3D camera is plugged into the Raspberry Pi.
I've been very disappointed with those. It's too much data. The processing requirements to do anything with them is just crazy. And there's a lot of proprietary or hard to reach drivers. If somebody else is having success with them, I'm happy as a clam for them, but I wasn't impressed.
they're a lot easier if you're just plugging them into your Windows 10 computer, but they're a challenge.
Okay, everybody. I think we'll get going. Say, James, can you turn your camera on? We are not seeing you. Maybe you do that on purpose, but we'd like to see you at least for your presentation.
It would help if I unmuted. I was talking for like 5 minutes there.
Don't you love it?
I've only been doing this for how long now, and I still can't figure it out. All right, there you go.
Right. All right, so you can go ahead and share your screen, put it up there where everybody can see it, and of course, if you've been attending our meetings anytime recently, you've probably gotten to know James a little bit, and he's got all kinds of interesting things that he works on, and this was a topic that popped up, I think I don't know, maybe it's been almost a year ago or something that you had mentioned this. I don't remember now when I first heard about this, but
I thought I did a presentation on it, but apparently I didn't. So you
may have, but not to us. I'm thinking
probably.
it maybe to somebody else, but because I think we talked a little bit about this, because I think I had a YouTube video that featured something like this, and then that spurred the topic. So anyway, I'm going to go ahead and let James Newton take over and share with us. Thank you, James.
Thanks, guys. Thanks, Steve. Appreciate it. So I just want to be clear, this talk today, although the introductory slide mentions my day job with Haddington Dynamics, which is a great company, and we have positions open, and you should definitely apply to come work for us. But this talk has absolutely nothing to do with them. And I'm mentioning that because I didn't go through their public speaking approval process. And so technically, I'm not supposed to mention that I'm associated with the company. Hopefully they won't see the recording and fire me over this. Anyway, I'm sure they won't. This is about WireBots, or bringing large-scale robotics to the real world at reasonable prices. Oh my God, I'll see myself out. And there's a couple of, just a couple of little pictures here about it. The thing that got me started on this was this SkyCam system. So I want to play this little video here. I'm going to try to full screen it, and we'll see whether or not you guys can. Let me know if you can't hear it, okay?
Coolest shots in sports broadcasting, the famous SkyCam. First used in the 1996 Olympics, SkyCam provides a unique perspective for the fan. But how does it work? SkyCam basically works by hanging a camera from 4 computer-controlled reels. Each reel outside the stadium holds 1,400 feet of cable that powers and flies the camera while sending the video to the computer hub on the camera deck through fiber optics. We're rigged to 4 points in the extremities of the stadium. We control that all from here. There's a camera operator. He pans, tilts, zooms, and focuses. I'm the pilot, so I use the software as well as this to move the camera. It's basically a Cartesian grid system. So here on the screen you see an overhead representation of what we call the fly space, and we use a computer to define boundaries that we can't go outside of for safety. All in all, it takes 9 people and nearly 4 days of preparation to bring you the world's coolest camera angle. It can be stressful at times. We can shut the game down if we're in the wrong place, so we really have to stay on top of it. But you know, it's more fun than anything. I've run all sorts of remote cameras, and nothing is more fun than this. So now when you're watching a game featuring SkyCam technology, instead of just staring at the screen on a replay going, whoa, that was cool, you can be that creepy, nerdy guy that says all the techie details about everything. It'll be awesome. Reporting from Ohio Stadium, I'm Ryan Koss for Palestra.net, the College Network. You know.
Yeah, I love that. Sports, go sports. Put the ball in the net thing for the point deal. Anyway, yeah, I'm definitely that nerdy guy. The thing I think was really interesting about this was I realized that these 4 cables that go off that are holding this middle part right here, they're all on a horizontal plane. May not be obvious in this shot, but they're all horizontal. So the question is, what keeps this camera from just like tipping or swinging underneath the thing? And as I thought about it, I noticed that they have this big old head up on top of the camera.
It's more fun than anything.
Okay. I can't really. Let me see if I can find a better shot that shows that. There it is, right there. So there's this big weight on the top, and there's a set of hinges in the middle here. This shaft connects through to the weight of the camera below. So if you jerk this thing by this center part to the right, the mass on the top balances the mass on the bottom, and it doesn't swing. I have never been able to confirm this, but I think they also may have a gyroscope or something up in the top of that dealy popper there. I've never been able to figure out what's inside that. But it was interesting to me to think about the fact that you could have something that's stabilized and able to move around without like constantly swinging or whacking around like a pendulum in the air. And then I thought about possibly applying that to other, types of robotics. And I realized that one of the things that we forget, I think, a lot of times in robotics is that we don't have to work on the same time scales. We use 3D printers that, you leave, the print goes overnight. And for a long time, I was pushing for like faster 3D printers. How can we print faster? How can we print faster? And that's a valid, it's a good thing to worry about. But I also had, some of the people that I was talking to were like, well, why does it really matter? You can be off doing something else to let the robot work while it works. So it doesn't really matter how fast the 3D printer is, because you can do something else. And you can just have 2 3D printers. So you double up the speed. So with a WireBot like this, even if it does swing a little bit, who cares? Just move it, let it stabilize, then let it do its job. Let it move from that point. I'm not sure if that's a normal Steadicam or not. I think it's for one thing, it's a huge camera. That whole head, if you look at it, is, I don't know, that's like at least 4 feet tall from the top of this down to the bottom of that. It's not something that a human being can lift on their own, but it may be based around the idea of the Steadicam. Actually, the basis of a Steadicam typically, or at least the ones that I'm aware of, is just mass. So what you do is you have a lot of mass. When I was a kid, I was trying to get a shot of riding a bike down a trail, and I couldn't figure out a way to mount it
I didn't have a helmet because this was the 1970s, and what were helmets on bicycles? So I couldn't really figure out a way to mount it to my head. I tried mounting it to a hat, didn't work. So I was mounting it to the handlebars, and it shook so much that it was just useless, right? So what I actually ended up doing was I had a friend of mine ride the bike. I stood on the wheel pegs behind him, and I held the camera, and we tried to film it that way. It was still too shaky. So then what I did was I duct taped my dad's very expensive Super 8 film camera to a pair of bricks, and the mass of the bricks, and they were like big old concrete bricks, I held those in one hand while he was riding the bike with my other hand on his shoulder and my feet on the pegs. And we got a very nice, very smooth steady cam shot, at the end of which he crashed. I fell off and broke my dad's bike, camera, and lost the film. Anyway, but I learned a lot about how to stabilize film. So at least I'm going to assume that film was steady because I never did get to see it. So this is the kind of the overall thing of the Skycam system here, and this is a slightly different version of it, a slightly more modern version than what you saw in that, but it's the same thing. They've got a stabilizing head up on the top, and they've got the camera down below. They have a system of 4 winches. I've never really been able to understand why they use 4. They use 2 cables on each one for redundancy, so that if one of them breaks, they don't drop the camera on a player. And I think you could get away with using 3. I don't understand why the need for 4 is. And there's a lot of other systems that all of them use 3. So again, I think the fact that they're using 4 is just for redundancy, just so that they have a way of controlling it. The thing that I like about this the most is, number one, it's unlimited airtime. So if you're using a drone to film something, you have a certain amount of time before the battery's going to, die on you. Number 2, it is more stable than a drone is in, for example, wind or in adverse weather conditions. Number 3, you can do it under computer control, and you know exactly where the thing is positioned, right? So one of the issues with flying drones is that they're dependent on GPS or on some other kind of inertial stabilization or something like that. So knowing exactly where that drone is can be very difficult, and this gives you a very stable positioning system. So one of the uses, well, I'll get to that later. Anyway, very stable, very safe, long-term, fairly low cost. It seems like a great system. So I just want to go through a few of the examples of how cable bots have been put to use in the real world. Real world, get it? Get it? One of those is the, so the video is, I think, actually wireless, Steve. Well, they said fiber optics, but I think that was the old one. I think they've since gone to, let's see if I can go back to that prior one. I'm pretty sure there's an antenna on this thing with the new one, but the old one was originally done through fiber optics. Yeah, real world. Some of us love a good pun. So another system that uses this that I think is really cool is the Maslow Cnc Router. I'm assuming you guys have seen this. If you haven't, boy, you got to check it out. It's really amazing. So there's a just off camera here, there's a motor, a winch, and over here there's a winch, and they're holding this mount right here, this white plastic, which is literally just weighted down with a pair of standard bricks on the bottom. I think that's a 3D printed or a cut piece of wood that holds the bricks. And then there's a ring in here in the middle that allows this this thing to stabilize. And then this standard laminate router. So these are Maslow CNC machines, are very, very low cost, very inexpensive to make. And you can, anything that you can cut out of a sheet of plywood, you can make with this thing. This is a fraction of the cost of 4x8 foot standard router. And it takes up almost no space because it stands up, right? You can literally just lean it up against a wall, and you still have all that working space available. The thing that I think it's the most wonderful for making is for things that require a whole series of very precisely cut baffles. So like, for example, a boat of some kind, or you can see this kind of artwork that's done where you make up a whole series of little things and stack them up. You know, you can really do very three-dimensional stuff with it in addition to the two-dimensional stuff. And of course, furniture is, you know, like the obvious thing. Unusual enclosures or housings. Looks like somebody's made a clock or something with it. So I just wanted to point that out. If you haven't had a chance to check out Maslow, I really recommend it. I'm not sure if I'll be able to show you a price really quick, but so this is the full-size one. This is the regular one, the Maslow Complete Kit. This is like fully made and assembled and everything's done. This is the one that you would typically buy. I'm not sure why the basic kit is less than the complete kit. Oh, it's made by somebody else. That's interesting. Who knew? They also have a metal version of it. Not sure that that's really ready for prime time, but there you go. And you can buy all the individual components. If you have some of it, but you need something else, you can buy it. This is the CNC motor. This is a simple DC motor with a gearbox and an encoder on it. That's all it is. $52 whole. I really think more people in robotics should be looking at that kind of motor and a servo system. You know, a good PID servo is not hard. I've designed one. Actually still have some of the kits available if anybody wants one. But you know, $52, you get an enormous amount of power out of that. So then the second thing that came about was this thing called the Flying Sky Delta. And I don't think I really have a picture of this anymore. If I remember correctly, this link, oh no, it is still working. Oh boy, I should have looked at this before the presentation. I'm not sure where it is on this. Not going to worry about that too much. It was an early version of the idea of building a 3D printer using using cables, using a cable pod. So all of this stuff is there. It's open source, all of the parts for it. Sadly, I'm not going to be able to show you a picture of it, apparently. That really sucks. That's bad. Sorry. But I'm going to show you one that's much, much, much better. This is, oh, here's a video of the prototype. Hold on, let's see if we can get that to play real quick. Yeah, okay, so this is kind of cool. So this is the point of tensioning that bottom piece, is to just use a pole. I don't know if you can see that black pole right there goes from the load point, which is down at the bottom, all the way up to an alternate or opposite load point up here at the top. Buffering. And then there's tensioning that's applied here. Those are springs. And one motor then runs both the bottom and the top in two different directions. You can see on the reel right there. These are just standard NEMA 17 motors. And then when you move it around, it's extremely stable. But think about what's going on here, right? The mass that you're moving is practically nothing. It's a single carbon fiber pole and the weight of the cables and the motor shafts, and that's all you're moving. So, okay, I'm gonna go ahead and leave that behind. Here is the most beautiful printer. I just love this thing so much. This is called the Arcus 3D C1. He's up onto the C3.
Hi, this is the Arcus 3D C1, and we just figured out kinematics. So I loaded up this object that I had previously printed on the other printer, and just loaded the model in here just to make sure everything's going in the right direction, and yeah, seems to be working. more importantly, well, actually, it's probably not more importantly, but in addition, I also figured out kinematic, or also figured out homing. So I'll show you that. Okay, so I just shut it off so I can, become free here and show you that homing actually works. And actually, I haven't typed any of these down yet, so print that out really actually works.
He told me he burned himself and decided not to stop in the middle of the video, but he burned his finger pretty bad just then.
Down and away from whatever axis I'm homing.
Oh, so he was saying he has to start up in the air because of the way that it homes. You'll see in a second the way that it homes.
At the same time, I'd be way below the bed, so I can't do that. So I have to do them one at a time, and they end up over here. But I have to start some distance above the bed for that to work. Some random distance above the bed. Now, here is homing. So what's happening is there's a bead up there, which is hitting my switch, and same thing up right in here, and in here. As it happens, see the hot end moves out and over. We're in there. Now we have a known location. So just to verify that.
So then what he's going to do here is show you that it actually was correctly calibrated when he did that. I love how confident he is about the machine at this point. And notice again that both the upper cable and the lower cable are running off of one shaft from the motor there in the background. Boom. Perfect. So I think the rest of the video, basically not all that interesting. Well, I don't know. He kind of shows it moving around a little bit, so maybe it is interesting. But there it is sliding around on top of that table.
My kinematics is working.
And you can kind of see the idea, if I jump forward here a little bit, is you can see how the pole is tilting, but the other cables, the way that the cables are set up, as they go down, they go up over these little pulleys and then go back down again, and they hold that platform where the print head is. They hold that platform perfectly level. Okay. So I thought that was a pretty cool little system. And if I can close this, I want to go back. He did some really interesting work here on 3D modeling, because there is an error that is introduced by the shaft. He's doing some stuff here with the extruder and the on the hot end, and he used he did the thing where you print with PLA and then you dye the parts, or you heat the parts, and he dyed them at the same time, which is kind of unusual, but I thought that was neat. You can heat them up in the oven, or you can heat them up in hot water. Either way, it works pretty well. Hold on, I want to get back to this other one here where he shows the, oh yeah, so as the cable goes around the spindle, there's a little bit of a positional error that's different between this one and this one because of the point where they hit the shaft. And what he did here was he brilliantly compensated for that with the shape of the point where the thing goes in through the hole. This guy, he is an absolute genius, and unfortunately not being utilized up to his full abilities here. But I also just kind of wanted to show you with this. That's not sped up at all. And the limiting factor here is very much the speed at which the extruder can run. He even built a special extruder with 3 heating elements in order to be able to reach what he calls ludicrous speed on the printer. So I thought that was pretty cool. Let's go back and take a look at the actual project. Bunch of updates. This is Hackaday.io. If anybody doesn't know this site, it's absolutely wonderful. Strongly recommend it. Has some of the best people on the internet on it, including me. So there's all kinds of good stuff here about how to build it, how it works, and so on and so forth. So I thought that was pretty darn cool. There's another guy who, okay, all right. So let me just point out here that one of the benefits of using a cable robot is that this is, just like a regular sized unit, but we've already seen from Skycam that you can go quite a bit bigger. And so people have gone quite a bit bigger. This is effectively the same thing with down cables. He didn't use the pole because he's limited by the size of the room, but he uses down pole cables as well as up pole cables in order to make a 3D printer that can print basically anything that will fit in a room. So, you can print absolutely massive, massive things here. So, oh, come on. Yeah, I know you're an old computer. Okay. So that was that. The maths, by the way, for all of that has been solved and published. So all of the kinematic stuff that's not a problem. It's already taken care of. Another outfit has come up with a patent. Don't you love patents? Patents are so wonderful. They've never built this printer. They've never done this. There's no actual photos of this thing, but they've patented the idea. The point here is that if you want an up pull as well as a down pull cables, you can provide that with a tensioning point that's held up by a crane. The idea here is that this crane is just pulling on that triangle as hard as it can, and these guy wires that are coming down are holding that triangle in a specific point up in the air. And then there's a second set of cables which are coming out here from the winches, which are actually then controlling the X and Y, X and Y position of the load point, and another cable which is coming up to that triangle and then coming back down again, which is controlling the Z height of that. So now you have it in tension from, in all dimensions, and you can move it around where you want to. So there's all kinds of interesting things that can be done with this. So I kind of wanted to go through what the use cases are. Obviously, we've already talked about, like 3D printing for really big stuff. It strikes me that it should be entirely possible to 3D print houses. And you can do that by, either the system that you saw on the previous slide, or through a set of 3 towers that are set up around the print area, or by just attaching the winches to buildings that are next door to the building that you're printing, right? So I could see a system where you use, initially use 3 towers, and then you print a couple of buildings, attach off of those, and then use 1 tower to print the 3rd building. And then you can keep going kind of in that triangular thing and just keep printing buildings as you go. I have a little bit of history, brace for self-promotion. For anybody who doesn't know, my main claim to fame, how many times have you guys heard me say this? Probably, what, 30, 40 times now, something like that, is I did the electronics, this driver system for the first 3D printed castle. It wasn't the first 3D printed structure, because it was a young man who 3D printed something out of foam, but this was the first 3D printed cement structure in the United States. It was back in 2015, and Andre has since gone on to do a bunch of other cool stuff. And then Alex LaRue was a graduate from Texas University who said, "Hey, you did this stuff for Andre. I need you to, do the electronics for us." They put it together in a slightly less attractive case, but there they are, all the same drivers. And they were able to get funding. Their little company called VestaPrint, or VestPrint, was purchased by Icon. And so you see their stuff all over the place. So the reason why I share that, aside from gratuitous self-promotion, oh my God, is that I would really love to work with somebody on building a big 3D printer like that for houses and things. Either directly printing cement or printing foam, which is then used as the form or the mold that the concrete is poured into. So basically, what in all of those cases where they were doing the 3D printed houses, what you have to understand is they were printing with cement, not concrete, and the cement was really just the form. So you would always see like two walls. You would see an outer wall and an inner wall, and then they would put rebar in between those two, and then they would fill the space in between those two with concrete. So what you're really doing is you're making a concrete structure. That is very well permitted in the United States. It's very well understood. We've been making concrete buildings for, goodness knows how long. So that's not a problem. There's really no reason that you have to use cement necessarily. You could 3D print with all kinds of different materials. You could extrude plastic if you had enough of it and a good enough extruder. You could extrude like expanding foams, and there's a number of different ones which are very low cost and quite strong. And I think with a little bit of buttressing, for example, which could be 3D printed, and maybe with some strengthening either fibers or poles or something like that that are laid in by humans as it's printed, you could then have something that you could pour the cement directly into, concrete rather, that you could pour the concrete directly into. And then you could remove those, or you could just stucco over them and they provide insulation. Unfortunately, I don't have the time, the space, or anything else, but boy, I would love to work with somebody on that. The other thing then is, what do you do once you've 3D printed that house? What do you do with the robot? You take it down and move it somewhere else? Okay, well, what if you didn't? What if you left it there? What if you just changed out the head, right? And put, for example, a camera on it? Then you could fly over your garden or over your landscaping and take pictures. So you know how you can stitch multiple pictures together? You could stitch together a really, really high resolution photo from 3 feet or 4 feet off the ground of your entire garden space. That level of record keeping is just absolutely invaluable. Imagine this: if you can look at a high resolution photograph of your entire garden every day, and then you start noticing that one of your plants is dying, right? Something's obviously wrong with this plant, right? This gives you the ability to go back in time. What was the initial symptom that we saw on that plant that indicated that something might not be, going well, right? Are any of my other plants exhibiting that initial symptom? More than that, machine learning systems are really cool and really good. And what do they need? They need data, right? So if you teach a machine learning system that this is what a healthy plant looks like, tell me as soon as you see this pattern starting long before the plant dies, but where it's starting to show some sign of stress, right? So another thing you could do is mount a set of pogo pins or a moisture probe on the head, and then drive that into the soil in different locations to measure the moisture levels. Then you can add a water line that goes over the top with a valve. Go ahead and water it. Some of you may have heard of farmbot.io. They do a XY kind of a router, sort of a CNC gardening system. This would allow you to cover a much larger space with much less equipment, and it would be a lot safer as well, right? Like this thing could work only during certain times. You put a motion sensor out in the backyard, and as soon as anything enters the backyard, it pulls up all the way to the top, out of the way, above everybody's head. Kids can't be hurt by it. It's going to be safe. The other thing that you can do is just have it pull up to a central location high up in the air, and then watch the garden. Do you see a rabbit, getting in there to the wascally wabbits coming to eat your carrots, right? You could detect that. You could look for motion. You could pretty easily then teach the robot to go dive bomb anything that wasn't welcomed in your garden, right? You can imagine how much fun that would be to write. You got squirrel problems, man, here's a solution for it right there. Now, don't worry, honey, these poles that I'm putting in the backyard and this whole cable system and this electronics box that I'm installing with these super powerful winches, they're all really just to keep the squirrels and the rabbits out of our garden. Yeah, raptor mode. I love it. So the other thing is that you could either put a gripper on it or something like the awesome auger. I don't know if you guys... Oh, it's no longer available. Oh my God, denied. Okay. So I don't know if you remember Billy Mays. He was a sales guy. He's famous for the, like, it slices, it dices, it, that kind of a thing, right? I always felt so sad for his family. I'm just wondering, like, does he do that voice around the dinner table or something? But he sold this thing called the Awesome Auger, and literally all it was a little, like a couple of metal blades welded on the end of a pole or of a rod, right? And you would put it in a drill motor, and then you go out and just auger your weeds, right? So we could put something like the Awesome Auger on it that could remove weeds or dig small holes. And then you could potentially come up with a way of sucking up some seeds from a bin and going over and dropping them into that hole, right? So now, and that would all be without any kind of additional stabilization. If you wanted more stabilization, you could run 2 wires vertically, one high, one low, which would, improve the stabilization a little bit. You don't have to necessarily have pull down cables in addition to pull up cables. You can have all pull up cables, but just having them coming from 2 different points. So the weight of the head is then still providing your downforce, but it stays vertical because of the two pull-up cables coming to different points on the pole. So just basically what you're doing is you're taking the basic thing. So imagine the basic thing with 3 cables going off in 3 different directions, and those all come down to the bottom part of the pole, right? And now imagine 3 more cables that are just placed above those 3 cables. So like go up 2 feet. You've got the pole on the load point that you're holding, so attach 2 feet higher, and then you've got a set of pulleys on each one of the poles that are 2 feet higher, and so you're running 2 wires from each reel, right? So those 2 wires roll up. One of them goes over the lower reel, one of them goes over the upper reel, and the lower reel cable goes out to the low point on the pole on the load head, and the upper reel cable goes out to the upper part of the pole on the load point. I really should have a drawing of that at some point. But anyway, so that's there. So now this here's my most brilliant idea for all of this. Okay, you got these pictures of your garden, right? And they're, on a day-to-day basis, you got this wide format picture. You load that up on a website, okay, and you offer it as a video game to anybody on the internet that wants to play it. They can look at your garden and they can identify the weeds in your garden and then click on the picture. And when they do, there's a little animated explosion that happens on the web page at that one point, right? And the one with the best people, Hackaday, hackaday.io. Hackaday.com is a blog site. Hackaday.io is the social media sharing site. So, okay. So you got this picture, you got people are clicking on it, and there's a little explosion. And what you do is you don't do anything. You just animate the explosion. It doesn't do anything, right? The game's called Weed My Garden. But what you do is when you get like a certain percentage of the people have all clicked in the same space, well, then that's probably a weed, right? So then you go and you actually, pull that out. And then you train the AI system based on that information to know that this is it's a absolutely stupidly brilliant system that could never possibly work. I did, in fact, make a winch. It does, in fact, work. I, in fact, do not have space to set up something that's actually useful, nor do I have the time. I don't know about you guys. Like, why do you get into robotics? And I got to tell you, the whole reason, hackaday.com. Now, that's the blog site. Now, if you go to hackaday.io instead, that's the social media or the sharing site. Hackaday.io, and you will find the most amazing projects there. So I got into robotics because I didn't want to clean my room. Isn't that why everybody gets into robotics? Is there any other reason to get into robotics than, like, if you're a kid, like, I'm going to build a robot and it's going to pick up my room for me, right? The problem with robots that can crawl around inside your room and pick things up is that they don't know where they are, right? The whole positioning thing is just a nightmare for robots. Not only that, you have to build a robot that can actually crawl over all of the crap that you've dropped on the floor of your room, right? So that's a problem, right? So there's all kinds of problems for a kid building a robot, right? But what if you allowed a kid to install pulleys in each corner of the room, right? And then you have a cable going along. So the way you route these, you have to understand the way you route these is you route the cable from the load point up over the pulley in the corner of the room, down the corner of the room to another pulley that goes along one wall and then around a pulley so that it goes along another wall back to the actual real system. So you have this little box that sits in one corner, and there are cables going out from that box, 2 cables going out along one wall, along the bottom of the wall, another cable going out along the bottom of the other wall, and then around pulleys and then out. And then the third one comes directly up from the box. So then the cables go up in the corners of the room, and then they come around the pulleys and they go back and they all meet at the load point in the center, right? The other way you can do that if you wanted to is you can have all 3 cables go straight up and then have the pulleys at the top of one corner so that they then separate out to go around to the other corners of the room, and then they come down, right? And really only need to do 3, don't need to do 4. There's usually one area that you don't need to get to. So then all you have to do is, see, the key here is there's no positioning errors. You know where the load point is through math, through trigonometry specifically, from the amount that the cable has been let out, right? So then you have taught a kid. I don't know about you guys if you've ever taught a class, but one of my greatest joys in teaching robotics to kids is that moment when you get to say, see, when you were in trigonometry, when you're learning math, you were sitting there saying, I'll never have to use this ever in my life. Every kid has said that in math class, right? And then you show them that if you use that, you can build a robot and be the envy of your friends because you no longer have to pick up your dirty clothes. So that's, it can be so simple. It's just starting off with, algebra, that new, anyway. So you start off with a really simple system that just has a claw or something that goes down, and then moves over a few inches and goes down and grabs it at the air. You don't have to identify where the clothes are. While you're at school or while you're outside of the room, the thing just goes down and tries to pick up everything at every possible position throughout the entire room. You program little exclusion zones where it shouldn't try to go and pick something up because, there's something there. And then you can, have it go over in front of a webcam or something like that if you have one and try to identify it, right? So then, like Lawrence said, you can train it to, this is clothes, this is a shoe, this is whatever, right? And then it goes and puts it in the right place. So if you think about it, the basic system is just 3 stepper motors and the drivers with kite string wrapped around the shafts. little NEMA 17 motors and $10 Pololu drivers and an Arduino, old network or phone cords to connect everything, because it's all low voltage, 12 volt, so this is not dangerous. I just think it's the perfect. So far, however, I have not been able to convince any of the universities or schools to fund the creation of that curricula, but there's all kinds of stuff that can be done with sensors and tools and end effectors and everything else. I just think it's a beautiful thing. So we've kind of seen the SkyCam thing. The other thing I wonder about is, why doesn't SkyCam deliver hot dogs? Right? Like, I mean, what I really want is to pull out an app, place an order, and have my hot dogs drop out of the sky on a little tray right in front of my seat. Nothing could ever possibly go wrong with that, right? But I just think it would be cool. And, if you can open a restaurant or something in a warehouse space and have one of these cable bots deliver your meal, I think that would be really cool. I also think it would be cool to have like a little, like a user interface robot, or maybe a screen that just comes around and drops down in front of the people at the table and then takes their order, talks to them or whatever, and then later on brings back the food. I just think that would be really cool. I'm not going to spend a whole ton of time on this because I think this is pretty close to the end of my time, but I always thought it would be really cool to do a kind of a game, a video game in real life. So if you can imagine, you go to a maker fair or something like that, and there's like a maze that's laid out on the ground, a maze of little rooms. And there's one of these cable bots that has a little load point with a magnet on the bottom of it, and the kids build a figure, or maybe it's just there's a figure attached to it. They don't necessarily have to build it, but the idea here is that this cable bot is going to walk this figure through this maze, and there's a camera on the load point that shows the avatar, shows the little creature, the little thing that's being held, going through the maze. So this is like a real life, like Dungeons and Dragons game, right? So you can actually see what's going on. The key is the kids program the robot to send the creature through the maze. So there's all kinds of cool online, like coding.com, and I'm trying to think of other ones that do this, where it's educational. You write a program and that controls the robot and makes the robot go and do something, right? So this would be like that, but it would be in real life, right? Like you would actually be able to see the robots moving. And if the avatar like bumps into the wall or something like that, there's a tilt switch on the load head that senses that and says, nah, you failed, and it goes back to the beginning again, right? There's all kinds of fun stuff that can be had with that. Yeah, I went on and on and on and on. I really got into it. I wanted to do it as a Maker Faire project. And the typical thing happened where a bunch of people said, yeah, we'll do it. And then, they didn't actually do it. Well, that's really interesting. It says that coding.com is a bad site when you try to click on the link. But I think that's the right one. No, it's not coding.com. I was wrong. JavaScript, learn, what is it? Programming game? I don't know. Code Academy is the one I'm thinking of. Oh goodness. Well, whoever's listening to this, don't go to. Wait. It's this one. Here we go. Yeah. Okay. It's I got it wrong. It's Code Combat. CodeCombat.com is a really cool one for learning JavaScript and Python programming. You have the opportunity to basically write these little programs that make your little character do things and react to stuff. And I actually got the preview thing as an instructor,
And I spent like days in the evening while we're watching TV. I'm like online playing the game. I'm evaluating it for students by playing it because it was such fun. Anyway, so I think that's everything on this whole WireBot presentation. I will stop sharing and ask if anybody has questions. Yep, no questions. Nobody ever does. The typical reaction is
it usually it takes a sec to kind of figure it out. Okay, it's like, okay, I know there was a question I had 10 minutes ago.
I think usually people think that's really cool, and then they're like, I'm never going to do that. But I really wish somebody would. I really wish somebody would play more with these kind of things. Several people have made cable bots. Some people, have run into the problems that cable bots have, which, they definitely are not perfect. There's issues with vibration and positioning and all that kind of stuff. There are a few like really highly professional people that are using them. There are a couple of companies that have done some really cool stuff. There is, for example, an outfit, university that did a whole thing with a cable bot there was a little load area, and that load area was holding a ball. Okay, and then what it would do is it would pop up like this to throw the ball into the air, and then go all the way around the ball and come back and catch it again. And it was balancing the ball like this, to keep the ball in the center at the same time. So they're doing all this feedback and then throwing it up in the air and catching it, and just showing how fast it could be. There's a bunch of stuff that's been done. There was and this is the other thing I want to do. Okay, so I got to tell you what I just pitched to the Burning Man crowd. And by the way, I have to say, Burning Man, I don't know if you're familiar with it, but a lot of people think that Burning Man is just about sex, drugs, and rock and roll. But let me tell you, it is about so much more than that. And it is about sex, drugs, and rock and roll, but it's also about a lot of other really cool things. And the burners, the people who go to Burning Man, are some of the nicest people I have ever met. They have a makerspace here in San Diego, and I absolutely love them. They're wonderful people. So what I pitched to them was, I want to build a really, really big version of one of these on steel with a chair that you strap yourself into, and then the thing takes you and like throws you around in the air and sets you back down again. Nothing could possibly go wrong with that. But the reason why I want to do that is because somebody did that. There is actually a YouTube video online of, it was a little enclosed room, like a little cockpit that you would get inside of. And then it had a screen in the front of it, and it was showing you, something like a roller coaster, or, whatever. And at the same time it was doing that, this cockpit is like doing all of the motion things. So it was a motion platform for one of those motion platform rides, but it was done using cables. And then there's another one that was using a cable bot to do precise unloading and assembly of parts. So it was taking parts off of a line, picking them up, aligning them, and putting them together. It was more of a demonstrator. And again, the idea behind this is that the mass is extremely low. You don't have all of that mass of like the support beams or the support structures or things like that. So when you start doing something big, it really works. So I think you guys up in Seattle, any of you that are really into gardening, you want to do something in your backyard, and if you're not married, then there's a chance that you might be able to actually do that. And if any of you are dumb enough to ever try to do this, don't hesitate to contact me. I would love to support your work.
So I thought of a question for you. So way back to the beginning, the cameras flying around the stadium, sports stadium. Let's take soccer as an example, because in soccer the ball doesn't stay down low. I mean, people kick it, and there must be somebody saying, deciding where those cameras need to be so that they're not in the way of a ball flying. I mean, you got cables, you got that big camera head. If the I've never seen them hit before. Is it,
Right.
are they?
Well, I think, and you heard the guy saying, like, we could stop the game, we have to be really, really careful with what we're doing. And it's almost never in the news. There was one incident that I'm aware of where two cables broke. And I think they broke because something really catastrophic happened with one of the winches. In other words, it wasn't the cable failed. It was something else caused both cables to fail. And the camera ended up on the field. So they had to call a pause. They had to get it out of there. And then you didn't have Skycam for that particular thing. But I think that what the answer to that question is, they get behind wherever the ball is going to go. So if you're playing football and you're going to kick the ball, you're going to go downfield, right? So they'll have the camera back behind it, so it has big space for it to go right out there. And in that case, then even the cables won't be a problem because they're going off to the side, right? Like if the guy kicks it far enough to the side that it's going to hit one of the cables, then that kick didn't matter anyway, right? It's going somewhere wrong. And as far as I know, it's interesting that you mentioned that, because to my knowledge, they don't use it at soccer games. Now, they still run Skycam at all the big NFL games. I mean, it's there, right? They run it because you can't use a drone to get those shots, because the drone could fail and fall on somebody, and that's a really big deal. The Skycam has a much lower failure rate, and also you only need one Skycam, whereas you would need multiple drones in order to keep running, because they don't have the the lifespan. Right? So this is the thing. I think Skycam is a victim of its own success because it's so good that nobody ever thinks about it. Nobody ever even, you don't even notice it, right? It's just there doing its job, and you're looking at these great camera shots, and nobody ever thinks, how are they getting that camera shot, right? It's just not thought about. And I really wish more people would think about it, because like having a hot dog delivered by Skycam, I think that would just be so cool, wouldn't it? I just love the idea. Watching that thing pop back and forth, delivering hot dogs to people all over the stadium. The problem with that is I wouldn't watch the game. I'd just be watching the robot. So anyway, all right, come on, guys. Somebody build a cable bot or do something fun with it. And if you do, reach out to me. I'd love to help.
One you didn't mention, you showed the CNC router on its side, right, with two cables.
The Maslow.
Yes.
Maslow, yeah.
So I hadn't seen that one, but I have seen people doing murals on the side of buildings with just two cables and some sort of drawing device hanging from the two cables.
Yeah, exactly. I actually stopped mentioning that one in this presentation because that's a lot of people have done that, and interestingly enough, people have made really accurate systems for doing that. Like there's a guy that has a plotter. As a matter of fact, I think it was one of the presentations here some time ago.
Could have been.
Do you remember that? You guys remember that? There was a guy who had a plotter sitting on his window that was a cable bot. It was it was either a 2 or a 3 cable bot, but it was he would literally just tape the piece of paper to the window, and then the thing would come around and plot on it, and it worked pretty well. It was the guy that did a mobile robot, the one with 4 tires, I think. Maybe I'm not remembering that correctly. I don't know. I'm old. I can't remember anything anymore. But the other one that I thought would be really fun was, and I actually pitched this to an artist as well and didn't get anywhere. But there's clubs that they go to where they do that bubble stuff, foam or whatever, that they pump into the dance floor, right? And people are dancing through it and all that kind of stuff. So what I pitched to him is, what if we used one of these cable bots to 3D print foam structures that people could then walk through and in and just destroy, right? So you could just, walk through a house and put your hand through the wall and whatever. I think there's some really interesting possibilities there. And then as it gets destroyed, you just, wipe it away and you 3D print another one, and then people can walk through that. I think there's all kinds of crazy fun stuff that you can have with art, both you know, additive type structures like 3D printers, and also, you know, something that moves over a surface, right? So how about spray painting cars? You know, my own car has a mural painted on the top and on the hood. And I think it would be fun to be able to do that too. Cars have art cars, or cars that are, you know, pinstriped or something like that by a robot that can then follow the contours of the car in three-dimensional space. So yeah, the possibilities with art, I think, are just about endless. Oh, I forgot. One of the other ones is just put an LED on the thing at night, and then have do the long exposure shots at night. So you get like a long exposure shot of a lake or with the moon or something like that, illuminating it, and then, you know, have some kind of artistic message or pattern or diagram or something like that drawn with the LEDs in the air in front of it. So yeah, so many opportunities for it.
Cool. Well, seems like, I mean, sure, we could keep on chatting about this all afternoon, but
well, I kind of doubt it. Like I say, people aren't that into it, but I'm hoping to inspire. I actually have to get going. I got to drive to headquarters for the rest of the week, so I will bid you a fair farewell, and I hope to see more online meetings and have a chance to see more cool presentations.
Quick question. Just the presentation that I have, are there any updates or changes to it or anything since you probably sent it to me about, I don't know, 4 or 5 months ago or so?
The one that I just gave, that presentation?
Yeah.
It's a live document, so it's a Google Doc. So
okay. So so I'll just be sure to pull down the latest of that. Okay. So I'll post that on the, you know, that'll be in the post for this month's meeting. So and then I'll kind of fix the chat when I put it together. All right. Well, thank you so much, James. We really appreciate the fun journey here on the, you know, cable bots and WireBots, or whatever the right, you know, I guess you can call them whatever.
Call them whatever you want. That's all it takes. You guys take care.
All right. Okay. Thank you. All right. Let's see here. Okay. Well, if there's let's see, if nobody else has, anybody have anything else to share here before I stop recording? If not, I will go ahead and conclude the recording, but we can, if anybody has anything they want to just chat about, we can certainly continue to do that. So anyway, thank you all for coming, and hope to see, well, I probably won't see you next month because I'm not going to be running the meeting, but somebody will be here doing it. So in any case, have a great day and a weekend, and see you next time.